Welcome once again to my YouTube channel. Thanks for watching my educative tutorial videos online. And if you have not subscribed, please do so by pressing the subscribe button as well as the notification button. And help me to share with your friends, with your colleagues, relatives, and so on, many more people, so as to reach more people better. Thank you. The topic we are considering today is gravitational field. What is gravitational field? Gravitational field is any region or space around the mass where gravitational force of the mass is felt. Then, let's talk about acceleration due to gravity. Acceleration due to gravity is the acceleration gained by an object due to gravitational force. The unit is meter per second squared, and it is a vector quantity, and the accepted value for the acceleration due to gravity is 9.8 meter per second squared. Newton's law of gravitation. This law states that the force of attraction between two bodies of mass m1 and m2 is inversely proportional to the square of their distance r between their centers, and it is directly proportional to the product of their masses. If you look at this law of gravitation very well, we can see that we can derive two statements from it. That leads us to the mathematical representation. Mathematical representation of Newton's law of gravitation. Okay, as I was saying earlier, I said in the Newton's law of gravitation, we can deduce two statements from it. We have two bodies, which is body 1 and body 2. Each body has its own mass. Okay, so the force of attraction between them is directly proportional to the product of their mass and inversely proportional to the square of the distance between them. So for the first statement, we have F is directly proportional to mass 1 and mass 2. The second statement is force is inversely proportional to the square of the distance r between them. So, merging the two statements together, we can have F is directly proportional to mass m1 and mass m2 divided and inversely proportional to the square of their distance. Okay, so this is the mathematical representation of Newton's law of gravitation. So from here, we have F equals to, if the sign of proportionality changes to equality sign, there will be a constant that will be added to it, which is our G m1 m2 over r2. The F there represents force of attraction, which the unit is Newton. That is capital letter N. The G represents the constant of proportionality, known as the universal gravitational constant. While the R represents the distance between the two objects, and the unit is in meter, of course. So from our formula, we have F equals to G m1 m2 over r squared. We want to make our G the subject of the formula instead of using F. So how are we going to go about it? We can see that this r squared under it is disturbing it, so we have to get rid of the r squared by multiplying it by r squared, and whatever we do to the right hand side, we have going to do it to the left hand side. So we multiply both sides by r squared. This r squared will cancel this r squared, leaving behind fr squared equals to gm1 m2. So from there we get our fr squared, which is equals to gm1 m2. Don't forget that it is g that we want to make our the formula. So we still have m1 and m2 beside this, which we are going to get rid by dividing both sides by m1 and m2. So we get divide both sides by m1 m2 m1 m2. So this m1 m2 will cancel this m1 m2. From there we get our g, which is equals to fr squared over m1 m2. So we can, from the formula, we can get our SI unit for the universal gravitational constant. The unit of force is Newton. The unit of distance is meter, and we have, don't forget that we have r squared, which will give us meter squared, divided by the unit of mass is kilogram, and we have two masses there. So kilogram times kilogram will give us kilogram squared. Therefore, the unit of our g, which is the universal gravitational constant, is Newton meter squared per kilogram squared. We want to look at the difference between, the relationship between acceleration due to gravity and universal gravitational constant. That is the relationship between small capital letter G and small letter g. Don't forget that the capital letter G represents the universal gravitational constant, while the small letter g represents the acceleration due to gravity. From the of force, we know that our force equals to mass times acceleration. Force is mass times acceleration, and using the Newton's law of gravitation, we get another formula for F, which is g m1 m2 divided by r squared. That is universal gravitational constant times mass 1 and 2 divided by the distance, the square of the distance between them. So from here, using our A as G, if you equate the two equations together, that is this F1 and F2, equating F1 and F2 together and representing our small letter A with G, we have our mg equals to gm1 m2 over r squared. So we can see that we have one mass here and we have two masses here. So one mass will cancel one mass. M here cancel this m1. So we have g equals to capital letter G m over r squared. Now let's assume that our mass and our distance there are constant. We can get that our G is directly proportional to capital letter G. That is, G is the relationship between them is the small letter G, which is acceleration due to gravity, is directly proportional to capital letter G, which is our universal gravitational constant, provided the mass and distance are constants. From there, we go to what is known as gravitational potential. What is gravitational potential? Gravitational potential is defined as the product of universal gravitational constants and mass to the distance r apart. That is gravitational constant times mass divided by the distance apart. From there we get the the formula of mathematical representation of gravitational potential. We represent the gravitational potential with V, that is capital letter V, which is equals to the product of universal gravitational constant and mass. Product of universal gravitational constant, which is G, and mass of the object, then divided by the distance apart. Okay, then from there we get to what is known as escape velocity. What is escape velocity? It is the kinetic energy which is needed at the Earth's surface, or its equivalent work done in taking the mass from the Earth's surface to infinity. The kinetic energy needed at the Earth's surface, or its equivalent work done in taking the mass of an object from the Earth's surface to infinity. From the definition of escape velocity, okay, we can see that the work done in taking the mass from Earth's surface to infinity is equal to the kinetic energy. The kinetic energy of the object. Then the work done, to calculate the work done, it is mass of the object times the gravitational potential, which is Gm over r. That is for work done. The formula of kinetic energy equals to half mv squared. Now equating the two formulas together, we have m times gm over r, which is equals to half mv squared. So this m will cancel this m. So we have gm over r equals to half v squared. Now multiply both sides by 2. So these 2 will cancel these 2. From there we have our v squared equals to 2 times gm over r. Don't forget that we are looking for the escape velocity, which is our v. Now we have v squared here, and we are looking for, we want to get only v. So this square is disturbing it. Then we can get rid of this square by square roots of both sides. So that means that this square will cancel the square root. So we have our v equals to root of 2gm over r. That is the formula of escape velocity.